Welcome to the lesson on High Voltage Workbay Safety for BEVs. High Voltage Workbay Safety is essential to BEV service and maintenance. In this lesson, we will provide you with a structured approach and guidance procedures to ensure the safety of technicians and the safety of the work environment. Let us look at our lesson objectives. By the end of this lesson, you will be able to explain how to maintain a safe BEV workbay when you work on high voltage systems. Next, you will be able to detail the list of steps to follow, which are essential to maintaining a safe BEV workbay environment while working on high voltage systems. And lastly, you will be able to describe the procedures that are needed to ensure your personal safety and the safety of the workbay environment while working on high voltage systems. What is a BEV workbay? A BEV workbay is a designated space in a garage or factory where BEVs are repaired or maintained. BEV workbays should include high-voltage electrical safety equipment, lifts, insulated tools, fire safety equipment, ventilation systems, and other equipment needed to perform these tasks safely and efficiently while considering the unique hazards of working with high-voltage electrical systems. Having insulated tools will help to prevent electric shock. The workbays should be well lit to ensure technicians can see what they are doing. These workbays should have non-slip flooring to prevent accidents. BEV batteries can be flammable, so having a fire extinguisher nearby is vital, and avoiding using any tools or equipment that could produce sparks is crucial. BEV batteries can produce toxic fumes if damaged to yeast, so it is essential to have a ventilation system in place to remove these fumes from the air. What is workbay safety for a BEV? A BEV workbay safety is the practice of taking precautions and following the correct safety procedures so that technicians can protect themselves and others while working on high-voltage systems. BEVs contain high-voltage electrical systems and batteries that can be flammable, producing toxic fumes if damaged. Technicians must always de-energize a BEV before working on it. This means disconnecting the high-voltage battery pack. It is always best to consult the manufacturer's instructions to determine how to safely de-energize a BEV. Technicians must wear the appropriate personal protective equipment. This includes insulated gloves, safety glasses, and a face shield. It is also essential to wear non-synthetic clothing and certified electrical safety hazard shoes. Posting safety signs and warnings in the work area will help remind everyone working in the workbay of the potential hazards. Technicians must be aware of the emergency exits and ensure they are always clearly marked. Work on high-voltage BEVs should never be performed alone. It should always be performed with others. This is because of the risk of electric shock, which can be fatal. Even if you are trained to work on high-voltage BEVs, it is always essential to have another person present in case of an accident. When working on high-voltage BEVs, it is important to check state laws and regulations to comply with all applicable safety requirements. Working on high-voltage BEVs in a workbay requires a structured and safety-focused approach. Here are guidelines segmented into 3 sections. The first section is pre-work, the second is mid-work, and the last segment is post-work. Let us briefly look at pre-work. 1. Plan and prepare. 2. Set up the workbay. 3. Secure and store the workbay and vehicle keys. 4. Wear the required personal protective equipment. 5. Check all tools and equipment. 6. Verify voltage using a voltage tester. 7. If applicable, implement lockout or tag-out procedures. 8. Ensure access to high-voltage components. The next section is mid-work. 1. Perform the necessary service or maintenance repairs. 2. Check the voltage levels periodically. The last section is post-work. 1. After the work is completed, conduct quality control and testing. 2. Clean up the workbay. 3. Complete all necessary documentation. 4. Unlock and energize the high-voltage system if applicable. 5. Perform a final inspection to confirm everything is in order. Let us now look at all these steps in detail. Let us now look at Section 1, Pre-work. In this section, we will look at how you can create a safe and controlled environment in a BEV workbay. Number 1. Plan and prepare. Before attempting any work on high-voltage BEVs, you must ensure that you are a qualified BEV technician with the necessary training and certifications. This typically involves completing specialized training programs and obtaining certifications that demonstrate your competence in working with high-voltage systems. Reviewing the specific manufacturer's documentation for the BEV model you will work on is essential as they differ from manufacturer to manufacturer. Review service manuals, safety guidelines, wiring diagrams, and technical bulletins to ensure that work on high-voltage BEVs is conducted safely and efficiently. Number 2, set up Workbay. A cluttered Workbay increases the risk of accidents. Tools, equipment, or debris left around can become trip hazards or lead to accidental contact with electrical components. An organized workspace will allow you to locate tools and equipment quickly, reducing downtime and improving overall work efficiency. High-voltage BEV components are sensitive and expensive. Removing unnecessary items reduces the risk of accidental damage during repairs or maintenance. Labeling the Workbay as a high-voltage zone is a visual reminder to all nearby personnel that electrical hazards are present. This awareness encourages everyone to exercise caution and adhere to safety protocols. Use high-voltage safety barriers to isolate the work area from bystanders if applicable. By cordoning off the area, you restrict access to authorized personnel with the necessary training and qualifications. This prevents unauthorized individuals from entering the potentially hazardous Workbay. Ensure that evacuation routes remain unobstructed throughout the entire process. Number 3, secure the Workbay and vehicle keys. The keys to the BEV Workbay, tool cabinet or toolbox, vehicle or digital key, diagnostic equipment, and any other keys must be properly managed and securely stored. Only authorized personnel should have access to the key storage area. Implement a sign-in and sign-out system that records who took a key when it was taken and when it is expected to be returned. This system helps track key usage and accountability. This helps maintain the security of the work environment, protect valuable tools and equipment, and prevent unauthorized access to BEV components and vehicles. Additionally, it is essential to have procedures for handling lost keys and securely storing them when not in use. The recommended distance is to store the keys at least 10 feet away from the vehicle. Always refer to the manufacturer's recommendations. Number 4, wear personal protective equipment. The purpose of wearing PPE is to create multiple layers of protection against potential hazards. Always ensure your PPE is in good condition, correctly fitted, and compliant with relevant safety standards. Put on the required PPE, including safety glasses, insulated gloves, arc flash clothing, safety helmets, safety boots, and any other specific gear mandated by the vehicle manufacturer for your vehicle and Workbay. Regular inspections and maintenance of PPE are essential to guarantee its effectiveness in safeguarding you from potential dangers. Number 5, check tools and equipment. Before each use, thoroughly inspect all tools and equipment you intend to use. Ensure any specialized tools designed for electrical work on BEVs are properly insulated. Insulation helps prevent electrical conductivity and the risk of electrical shock. Look for any insulation damage or wear signs, such as exposed conductive parts. Some BEV brands and models may require specialized tools. These tools should be in excellent condition and used according to the manufacturer's recommendations. Number 6, verify voltage. Voltage verification is a critical safety step to ensure the high-voltage system is de-energized and safe to work on. Choose a voltage tester that is appropriate for the voltage level of the high-voltage system you will be working on. The voltage tester should be rated for the highest voltage you may encounter. Before attempting any work on the high-voltage system, use the voltage tester to confirm that the system is de-energized. This means there should be no electrical potential in the circuits you will be working on. Always follow the manufacturer's guidelines and best practices for voltage testing, and ensure the voltage tester is properly maintained and calibrated for accurate readings. Number 7, implement lockout or tagout. If applicable, implement lockout or tagout procedures to isolate and de-energize the BEV's high-voltage system. Lockout or tagout is a safety procedure to prevent machinery or equipment's unexpected energization or startup while technicians perform service or maintenance. Place the lockout devices, such as padlocks or lockout tags, on the power sources and control mechanisms deactivated during the shutdown. Lockout devices should prevent the re-energization of the high-voltage system by physically blocking switches, breakers, or connectors. Attach lockout tags to the lockout devices. These tags provide information about the maintenance or repair work, the personnel responsible, and contact information. Follow manufacturer-specific instructions for safe shutdown. Number 8, access to high-voltage components. Consult the manufacturer's documentation, including service manuals and safety guidelines, to understand the procedures and precautions for accessing high-voltage components. Identify the panels or covers that need removal. Before removing any panels or covers, confirm that the high-voltage system is de-energized using a Cat3 digital multimeter. Follow a methodical process for removing panels or covers by checking the manufacturer's documentation. Once you have removed the necessary panels or covers, follow the manufacturer's guidelines for accessing the high-voltage components. This may involve additional steps, such as removing insulation barriers or protective covers. Store the removed panels or covers safely and securely within the work area. Keeping them organized ensures that they can be easily reinstalled later. Let us now look at Section 2, Mid-Work. In this section, we will look at how you can maintain safety throughout the entire repair or maintenance process in a Workbay. Number 1, plan and prepare. Perform the necessary repairs, maintenance, or diagnostics on the high-voltage components, following the manufacturer's procedures and best practices. Use insulated tools and equipment designed for high-voltage work. Pay careful attention to torque specifications and refer to the manufacturer's manual when tightening fasteners or connectors. Over-torquing or under-torquing can lead to issues with connections and component integrity. Conduct quality control checks throughout the repair or maintenance process to ensure all work is performed correctly and to the manufacturer's specifications. Number 2, conduct voltage checks. The frequency of voltage checks should be determined based on the specific work performed and the manufacturer's recommendations. Voltage checks may need to be conducted periodically throughout the work, especially if the work involves multiple steps or interruptions. Whenever there is a work interruption, such as taking a break or temporarily leaving the work area, perform a voltage check before resuming work. This is especially important if any electrical system or component changes have occurred during the interruption. Maintain continuous awareness of the high-voltage system status throughout the work. If you suspect the system has become energized at any point, immediately stop work and retest for voltage. Encourage a safety-conscious culture and make it a standard practice for everyone involved to monitor and verify the de-energized status of the high-voltage system. Let us now look at Section 3, Post-Work. In this section, we will look at how you can follow proper post-work procedures to ensure a safe and successful completion of the process in a Workbay. Number 1, conduct quality control and testing. After completing the repair or maintenance work, thoroughly inspect the high-voltage components and the surrounding area. This quality control inspection helps identify any issues or glitches that may have occurred. Perform a visual inspection of the components, wiring, and connections to ensure everything appears in order. Look for loose fasteners, damaged insulation, or any physical damage or wear signs. Functional testing ensures that the high-voltage system operates correctly and safely. The specific tests may vary depending on the nature of the work. Functional tests can include voltage and current testing, component functionality, system integration tests, insulation resistance testing, and functional test sequences. Perform diagnostic scans only if applicable. If the vehicle has diagnostic systems or software, scans and diagnostic tests are performed to identify potential faults or error codes. Address any issues that arise during the diagnostic process. Number 2, clean up the workbay. Collect and dispose of any waste materials. This includes used disposable items, packaging materials, and any debris that may have accumulated. Properly organize and store all tools and equipment. Ensure that they are cleaned and returned to their designated storage areas. Verify that no tools or equipment are left lying around, reducing the risk of tripping hazards. Safely remove and store PPE. Inspect PPE for damage and perform any necessary maintenance or replacement. Clear the work surfaces of any remaining tools, materials, or equipment. This is important for maintaining an organized and uncluttered workspace. Thoroughly clean the work area, including any spills, stains, or debris. Clearly label and identify any high-voltage components or panels removed during the maintenance or repair work. Use tags or labels that indicate their nature, purpose, and any relevant information. Use lockout devices or secure mechanisms to lock and secure the high-voltage components or panels in their designated storage areas if required. This prevents unauthorized access and ensures the safety of these sensitive components. Store high-voltage components or panels in a controlled environment that meets manufacturer recommendations. This may include considerations for temperature, humidity, and protection from contaminants. Number 3, complete the documentation. Maintain comprehensive records of all work performed. Document all voltage measurements taken during the maintenance or repair work. This is vital to confirm that the high voltage system was de-energized and remained safe during the procedure. Record the adherence to safety protocols and PPE used. Keep a record of the tools and equipment used. Note any specialized equipment or insulated tools used for high voltage components. Document any components replaced or repaired, including the make and model of the component, serial number, and the reason for replacement or repair. Document any emergency procedures implemented, including responses to unforeseen issues or energization events. Detail the steps taken during the maintenance process to provide a clear history. If the BEV is equipped with data storage systems or diagnostic tools that record data, ensure that this data is adequately backed up and documented. Number 4, unlock and energize if applicable. If the high voltage system was de-energized, follow the manufacturer's procedures to safely unlock and energize the system. These procedures can vary among different BEV models and must be followed precisely. Wear the required PPE. Carefully monitor the high voltage system during the startup process. Watch for warning lights, system alerts, or unexpected behavior that might indicate a problem. Be prepared to immediately halt and reverse the energization process if any issues or malfunctions are detected during the startup or functional testing. After successfully energizing the high voltage system and conducting all necessary checks, confirm that the system is fully operational and safe for operation. Number 5, post-work inspection. Perform a final inspection to confirm everything is in order and safe for operation. This protocol should include visual checks, such as loose fasteners or anything that appears out of place, functional checks, such as testing sensors, and safety checks, such as lockout or tag-out procedures. Ensure that the high-voltage system remains de-energized throughout the post-work inspection. The post-work inspection is the last line of defense to verify that all work has been conducted effectively and that the BEV is safe and ready for operation. Thorough documentation of the inspection results is critical for quality assurance, safety records, and future reference. Verify that the vehicle is safe for operation and that all work has been successfully completed. Let us now cover what we have learned in this lesson on high-voltage safety for BEVs. Starting with Step 1 in pre-work, ensure you are a qualified BEV technician with the necessary training and certifications. Review the specific manufacturer's documentation for the BEV model you will work on, including safety guidelines. Step 2. Clear the Workbay of unnecessary tools, equipment, or debris to maintain a clean and organized workspace. Verify that the Workbay is properly labeled and cordoned off to restrict access to authorized personnel only. Step 3. Ensure all the keys are properly managed and securely stored. Step 4. Put on the required PPE, including safety glasses, insulated gloves, arc flash clothing, safety helmets, safety boots, and any other specific gear that is mandated. Step 5. Inspect all tools and equipment to ensure they are in good working condition and properly insulated. Step 6. Use a voltage tester to confirm that the high voltage system is de-energized and that no electrical potential is present. Step 7. If applicable, implement lockout or tag-out procedures to isolate and de-energize the BEV's high-voltage system. Follow the manufacturer-specific instructions for safe shutdown. Step 8. Remove panels or covers to access high-voltage components if necessary. Follow the manufacturer's recommendations for safe access. For the mid-work section, Step 1 is to perform the necessary repairs, maintenance, or diagnostics on the high-voltage components, following the manufacturer's procedures and best practices. Step 2. Use insulated tools and equipment designed for high-voltage work. Periodically check the voltage levels to ensure they remain de-energized during the work. In the post-work section, Step 1 is to double-check and verify the repair, service, or maintenance quality after the main work is completed. Perform functional tests to ensure the high-voltage system operates correctly. Step 2. Clean the work area, removing waste, tools, or equipment. Step 3. Complete all necessary documentation, including records of the work performed, any voltage measurements, and the completion date. Step 4. If the high-voltage system was de-energized, follow the manufacturer's procedures to safely unlock and energize the system once the work is verified as complete. Step 5. Perform a final inspection to confirm everything is in order and safe for operation. Remember that working on high-voltage BEVs is highly specialized and potentially dangerous. Always prioritize safety, follow manufacturer guidelines as they differ from manufacturer to manufacturer, and stay up to date with the latest safety practices and equipment. Thank you.